All right, last lesson, we talked about theoretical probability. In theory, every time I roll this dice, it should be an equal chance that each number is even chance that each number will roll. So if I was to roll the dice 6 times, I should get each number once each, right? Theoretically, I should. Experimentally, though, that is very unlikely to happen. Okay, so there's 2 different types of probabilities here that we need to talk about. Theoretically, yes, every 6 times I roll it, I should get one of each number. Okay, experimentally, you know from playing board games that doesn't always happen. Sometimes it seems like you might get an awful lot of 6s, or there's always one number that seems to come out a lot more than others. And that's what we call experimental probability. What actually happens when you roll that dice? Okay, so experimental probability, to calculate it, we have pretty much the same formula here. It is the number of times that the event occurs over the total number of trials in the experiment. But to calculate that, I'm going to have to give you stuff like this, where I tell you the numbers that roll. If I roll the dice 10 times, they're the numbers that I actually get. Okay? The other thing that you're going to have to be able to find is the expected number of occurrences. Not now. Okay, sit down. No. How many times would you expect to roll a 6 if you were to roll the dice 60 times? Do you want to have a go? Well, 10. Very good. To find that, what you do is you find the probability, the theoretical or the experiment, depends on what you're given, the probability of rolling that number times by the number of trials that you're going to complete. So that's a little formula that we're going to be using. Okay, so here are our questions. When playing with a spinner with the numbers 1 to 4 on it, the following numbers come up. So we're doing the experiment, and I spin once and I get a 1. I spin again, I get a 4. Every time I spin it, these are the results that I get. Okay? The question is, what is the experimental probability of getting a 3? Well, when I look through that list, the number of times that I get a 3 is, there's 1 here, 2, 3, 4. There is 4 times that I get a 3. Okay, so that's the number of times that the event occurs. Then I also need to know the total number of trials in the experiment. That's how many times did I spin that little spinner. And so I just want to count up all the numbers, whether they're 3s or not. I count up all the numbers in that list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 times that we spun that spinner. So to find the probability of getting a 3 experimentally, I got 4 3s out of a total of 10. Remember that fraction is our preferred way to leave our answer unless we are specifically asked for a decimal or a percentage. But we do want it to be simplified. So 4 over 10, you can divide the top and the bottom by 2, which would give a 2 over 5. Okay, let's look at question B. What is the experimental probability of getting an even number? That's still talking about the same list of numbers up there. I want to know how many times the event occurs. The event is for even numbers. So I go through and I count up my even numbers. 1 there, the 4 is even, another 4, and the 2 is even. So there is 3 even numbers out of a total of still 10. Okay, so still the same 10 numbers as before. So the probability of even is 3 out of 10. There's an extra equal to sign there if I can simplify, but we can't simplify 3 over 10, so there's nothing to put in there. Okay, part C. We want to know the expected number of 3s if we ran the experiment 1,000 times. So this is that second formula that I was talking about up here at the top of the page, the expected number, which is the probability times the number of trials. So it's written here again for you. Expected number of 3s is going to be the probability of getting a 3 times the number of trials, which we know was 1,000 for this question. Because it told me I did the experiment 1,000 times. I just calculated the probability of getting a 3. It was 3 out of 10. No, it wasn't. That was the even ones. The 3s was the 2 out of 5. That was part A. I was looking at the wrong one. I want to times that by 1,000. Okay, now you can use your calculator for this part. You don't need to do that in your head. So you type in 2 over 5, and I want to times that by 1,000. And that means that there is 400 times that you would expect to get a 3 if you spun that spinner 1,000 times. Okay, remember that expected one. Often catches a few people. Okay, so your work today is on pages 8 to 10 of your work booklet. So there it is, worksheet 3. And you'll see the question looks very similar. You don't have to write out those wordy parts like I did. That was just to help us work through the question. Sit down for me, Stella, please. So the first one says, what is the experimental probability of getting a 3? Your data is up here. So how many 3s are there? You count them up. There's only 1 3. So the probability of getting a 3, there is 1 3 out of 10. If you count up how many numbers there are there is 10. Okay, so I got you started. You can go on from there.